5.5, negative exponents and scientific notation. Before we had the quotient rule we would use here, and so that means we would subtract to get our answer. But what happens if our small number exponents on top, then when we subtract, we're going to get a negative answer. And so what do we do with that negative exponent? Well, this negative exponent is going to become 1 over x squared. So we have a rule that says if we have a number with a negative exponent, then it's going to change locations. And by locations, I mean the numerator or the denominator. For the most part, when we see a whole number, we really don't think of it as being a fraction. But when I have the number 3 and I write it as a fraction, then it would look like this over 1. And so when I talk about a whole number and its location, I'm really talking about the numerator. And so we want to keep this in mind when we are looking at negative exponents. So that if I have that x to the negative 2 and I look at my rule, then what it tells me to do is take this and change locations. And so it's in the numerator because it's a whole number, and so it would go into the denominator, and then the exponent will become positive. And if we don't have a number in the numerator, we have to put a 1 there just to hold the place. So if we had 3m to the negative 5, remember that your exponent only affects what it touches. So in this case, the m will move to the denominator, will change locations, but the 3 will stay in the numerator. Okay, so we want to remember this changing locations thing if we have a negative exponent in the denominator. So if I have 2 over x to the negative 8. No, I don't want that either. Because of the negative 8 is in the denominator, we're going to change locations, which means we're going to basically come up. So now let me go ahead and put that fraction line, because I would come up, and then my exponent becomes positive. Whatever else was there will stay there. Now, when I look at this fraction, there's nothing in the denominator, so I'm going just to write it as a whole number instead of a fraction. So then the rule here is x, well, 1 over x to the negative n is going to equal x to the positive n. So this is what we want to remember about our rule here. And then let's go back up here and here. And then you want to remember this little tidbit about changing locations. So we want to have both of those probably on a 3x5 card. So while you're studying, you'll be doing your homework, you'll be using the right rule. So then, if we had, change that back to black. Now remember, only the number that has the negative exponent, the number or the variable, that's the only thing that will move. So it'll change locations. The exponent will become positive, and y to this 6 just stays where it is. Here, since they have the same base, we can look at this as the quotient rule, or we can remember that, you know, this comes up. So you've got a couple of different ways to look at this. We can look at it as the quotient rule, where we'd have p to the 8 minus the negative 6. That's what the quotient rule says to do. Those two negatives will become a positive, and so we're going to end up with p to the 14. Another way to think about this is with the negative exponent rule that says we bring that p to the negative 6 up and change that to a positive 6. Now we're looking at the product rule. So here we had the quotient rule. Here we're using the negative exponent rule and the product rule. And so the product rule says add, and so we're going to get p to the 14. As you work through this, you'll probably start noticing that, you know, I talked about when this changes locations. So even though we didn't talk about it in the negative exponent rule, here we did this with the quotient rule. It's still that 6 ends up being a plus 6. So whether you're doing this rule or you're going this direction, when it changes from one position in a fraction to the other, it's going to take on the opposite sign. And so if it's negative at the bottom, it's going to become positive when it goes to the top. Negative 5 to the negative 4, take care of your exponent first. Order of operations tells you to do that. And remember that exponent goes with everything it touches, so the whole negative 5 comes down, and then this becomes a positive 4. So this means we're going to multiply this 4 times. And an even number of negatives will give us a positive. 5 times 5 is 25. 25 times 5 is 125. 125 times 5 is going to give us 625. Here, remember only what's being touched. Changes locations. If you have a negative exponent with a fraction, just flip the fraction, make the exponent positive. 3 over 1 is just going to be 3, and we're going to do it 3 times to get 27 as our answer. Remember, this is going to put the 4 into the denominator, so we're going to end up with fractions. The 1 becomes positive, the exponent. Now we have 1/4 plus 1/3, which means we're adding fractions. So we need a common denominator. We'll use 12. 4 times 3, so 1 times 3. 3 times 4, so 1 times 4, and we add this together to get our answer of 7/12, which it doesn't look like when you start here that you're going to end up with a fraction. So That's very interesting. These negative exponents are very different from what we're used to seeing. If you have a negative exponent in an expression that has several steps, sometimes it's easier to use the other exponent rules first, and then take care of that negative last. So here I'm multiplying, so this means the product rule. So negative 2 times 3, x to the 5th times x to the negative 2, y to the negative 5th times y cubed. And then here I'm going to be using the product rule, which means I'm going to add. So I have negative 6x cubed y to the negative 2. And now I want to finish by taking care of this negative exponent. So negative 6x cubed over y squared is going to give me my answer. Likewise, if I have an expression and I need to use the product rule, I'm going to go ahead and do it before I take care of the negatives, because in here I'll end up a negative times a negative is going to give me a positive, and then here I'll get a negative, and so then to finish it I'll move that negative exponent into the position that it needs to be. That's going to be the best way to handle the problems where you're having to use the other exponent rules. Now, the negative exponent does come in handy, especially for writing a very large, or very small numbers. And so let's look at what some of you may be seeing in your other classes. If you're in a science type field, then you may be learning how to use scientific notation. Now, scientific notation has a very specific look. It is only one digit. Okay, I'm going to say 1 and only one digit. It must have 1. It can only have 1. One and only one digit before the decimal, and then you're going to use the x to show times a power of 10. So it's a very particular look to it, and so we want to be sure that we've got the right look. All right, so if I have a number like 3.2 times 10 to the 5th, this is what scientific notation looks like. I've got one number in front of the decimal times 10, a power of 10. If I want to expand that, then I'm multiplying, and it's really, if you think back when you're multiplying by 10, 100, 1,000, in the end, the shortcut is we just move the decimal. The same number as the zeros. So we're going to do the same thing here. I've got 5, and so my decimal is going to be moved 5 places. So there's 1, 2, 3, 4, 5. And if there's not a number there, I'm going to have to add some zeros. So this answer is 3, 2, and then 1, 2, 3, 4 zeros. And then come in and put your comma. So this is a shorthand way of writing 320,000. Scientific notation. And so when we're looking at large numbers, the exponent will be positive. In science, we need a way to represent very small numbers, and so again we could have 4.5 times 10 to the negative 8. So this is scientific notation. Also, we've got that one and only one digit in front of the decimal, times with the x, 10, a power of 10 to the negative 8. Now, up here, we went to the right 5 places. Here, negative tells us we're going to go to the left. And so, again, we're going to take and we're going to grab this and we're going to go 1, 2, 3, 4, 5, 6, 7, 8. And then that is where our new decimal will be right in the front. So this is going to equal decimal 1, 2, 3, 4, 5, 6, 7 zeros. And then our 4, 5. Very small number. So for a very small number, the exponent I didn't write that up here, will be negative. Let's see, I didn't cross my X up here. There we go. All right, so it's going to be important for you to understand this little tidbit here. So I'm going to put some stars by here. Let's use a different color here and here. This is going to be very important because what you're going to do is you're going to be counting. You know, if we want to take, let's say, 565 million, and we want to write it as scientific notation. Then we want to show where our exponent would go. Our exponent, or not our exponent, but our period. Our period's going to go right there when we write it as scientific notation. So we'll have 5.65 times 10. Now my old decimal is right here. And so I need to count the spaces between my new decimal and my old one. 1, 2, 3, 4, 5, 6, 7, 8. And because this is a large number, this is going to be positive. Now this is a very small number. Very small number. So our own exponent's going to be negative when we get done here. So here's our old decimal. Here's where my new decimal needs to go because I can only have one digit in front. So I've got 3. Let me change that back. 3.29 times 10. And then I have to figure out my power between my old and my new decimals. So between these two, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is a very small number. So I've got to be sure and make that a negative 9. Okay, not too much to this chapter. Hopefully you've seen scientific notation before. And it shouldn't be too hard if you just remember to put a negative for your small numbers and a positive for your large numbers. Only one digit in front, and it must have one digit. That's how we write it in scientific notation. All right, so go do your homework and talk to you next time.